Hi, my name's Mark Smart. This is my video for the Dogwood Scholarship. I hope you enjoy. My video is on engineering. This is one of the first projects I've ever done. It has also made me want to continue in engineering. It is an airplane that me and my good friend Blair have built. It is an air-powered airplane. We started off with a very simple design, as you can see in this video. We continued on to make different iterations and improve our design, but unfortunately when we did improve it so much, it did so well, it flew away and we were never able to find it. We weren't recording the incident, so we have no proof of that, but that didn't matter and we continued on to make a new airplane, this time with electric motors. We continued on for this project for a while, and it worked out pretty well. Another project that we did was called an HHO generator, which produced hydrogen and oxygen, and that can be very explosive. This was a very fun project and one of my favorites that I've done. We've done many other things together, such as me getting stuck in a big old TV. In grade 9, I decided to join the robotics club at school. This is the first robot that we built. You can see from this video that it didn't drive the best, but eventually we did fix this problem, and it turned out to work pretty well. Here you can see it completely finished. Since this was our very first robot, there was obviously mistakes that we had, and we tried to fix them in the next versions that we built. We were able to get a new system that had much stronger motors and much bigger capabilities. The aim of the competition was to get cubes stacked in the corners of each side of the square that you're playing in. You can also stack the cubes up on top of towers that have spots for them to sit. They're different colors, and if you get some of those colors stacked on top of the towers, you can get extra points for the ones you have stacked in the side. You are either on the blue or the red team, and you can see from this picture how the field is set up. We were building robots that you would normally see, but at one point we decided to try something different, something new. We used pneumatics, which is air-powered pistons, that would extend out arms that would block the other players from getting where they need to go. So it was just a defense robot that kept them away. Here's a large gearbox that we made that would lift up the arm with cubes on it and put them in the towers. In this video you can see that we have a robot and it is going in and keeping the other robot from getting the cubes it's trying to get. It did good, and this robot wasn't able to get any of the cubes that it was trying to get. Outside of the robotics team, I've also been in the track team and cross-country team at our school. Outside of school, I am in Air Cadets, as a Warrant Officer 2nd Class, the second highest rank you can achieve in Air Cadets. In Air Cadets, we do a lot of community service, such as going out and collecting donations for the veterans and handing out poppies on Remembrance Day. And back to engineering. Engineering has always been a big part of my life when I first found out about it in grade 9. I love it so much that I even do it outside of school all the time. It just impacted me so much, and I have so much fun doing it. A big part of the game is at the beginning, when we have a 15-second autonomous period. This is where we have code that will program the robot to do it without us controlling. As you can see in these videos, I have a robot here that is programmed just to push the one block into the cube. Of course, this was just a small one, but there's many things that you can do with this code and make it do many other great things. The last video and this one are both code that we use for the robots. This code is for the newer system. The code here is for the most recent robot that we built that went into a competition. Here it is in the beginning stages, as we first started to attach parts, and here it is finished in the arena, ready to go. This is some code that I used for a robot that I decided to build. The robot that I was building is a completely autonomous robot that would control itself and do everything all on its own. The code tells this robot that when it hits a wall, it needs to turn around and start driving again until it hits another wall. There's light sensors on it as well, just to make sure it won't go down any flights of stairs, basically like a Roombot. Here's a project that I did for school. It is just a small coding project that spells out all the initials in my name. I love to do stuff like this, which is coding, and I plan to go to university at SFU for computer science to learn more about software engineering. One of the biggest accomplishments that we've had in robotics would have to be coming first place in a round robin at one of our competitions. It was amazing knowing that our robot did so well in this competition. Another big thing that I've done in engineering is 3D printing. This is the bigger 3D printer out of 4 that we have at our school, and the one that I primarily use. The 3D printer works by going back and forth, melting plastic, and laying it down, layer by layer. As you can see here, it's filling in one of the clips. It is going at double the speed as it normally would. And here's my own 3D printer that I have at my house. Some projects I do just for fun, such as a turtle that I made. You can see it swimming and moving. This just shows how precise and how accurate the 3D printer can be to make moving parts. Here's a bunch of other small projects that I've done. I made a bunch of roses for Valentine's Day that we gave to Students for Kindness Month. A lion book holder, a bouquet of roses in a flower pot, and even a skull that holds pen and pencils. These are just some of the projects that I've done. Here's a 3D printed keychain that I made a while ago for when we went down to California to Disneyland. We gave it to all the staff that helped us and showed us around when we were down there. Here it is in the CAD software, which is Google SketchUp, where I designed it. This is a clip that goes on the back of the head, and it holds the elastics from face masks away from the ear so it doesn't cut into them. Thanks to Mr. Craich, I've made over 250 of them for the Maple Ridge Hospital. I printed out other iterations too, such as this one. It is a lot thinner design, and it is a lot lighter on the head. Some doctors or nurses prefer this one over the other type that I made. I've done many other projects in engineering that I wasn't able to fit in this video. Thank you for taking your time and watching my video today. I hope you enjoyed, and thank you again for considering me for the scholarship.